Good afternoon, everyone. Thanks for coming. I wasn't expecting quite such a full house. So, as you said, my name's Daniel. This is my colleague Mario. We're from eBay. So, just a little bit of introduction about us. We're both software engineers. I work in the London office. In my spare time, I'm a bit of a tinkerer and a hacker of electronic devices. And I suppose I describe myself as a bit of the resident mad scientist of eBay.
And I'm also a software engineer at eBay, and basically in my spare time I 3D print stuff, and of course I'm a complete fan of Doctor Who. So yeah,
that's us. What do we want to talk about today? We'd like to just start off with a little bit of an introduction to Docker and why you might want to use it in some of your tests. In particular, we'll be looking at how we've used it in some of our tests. And then go through how you might integrate that into a Scala project and talk about some of the lessons that we learned and some of the ways that we've used that for testing one of our projects. So without further ado, let's start off with an introduction to Docker. How many people have used Docker or have heard of Docker before? Okay, so a significant majority of people. Before we get into Docker, I'd like to take a quick step back and talk about virtual machines. So virtual machines are eBay's default way of working. They're sort of our unit of compute that we use internally. And we've got an internal cloud which we can provision machines on. We've got a nice UI for it. We've got a choice of OSs. So it's all very good for us as a way of deploying stuff. Except it's a little bit slow. Bringing up a virtual machine is not cheap. It takes time for the container to be provisioned, for everything to come up. Machines can and do disappear, and because we're based in Europe, there's that little bit of connection latency where eBay's infrastructure is mostly based in the US, so we have to wait for all of that to come through. And it just makes our lives a little bit more tedious while we're waiting for things to come up. So it's also, sometimes it's not possible to easily automate things, particularly in the case where you're dealing with maybe a database or a web server, message queues, or some sort of proprietary dependency from a third party. Sometimes those things require a little bit of state that's not very easy to bring up in a virtual machine. You might have something like Chef that can allow you to do that, but it still requires a lot of time and investment. So this is where Docker came in for us. So Docker, the website, describes it as an open platform for sysadmins and developers to build, ship, and run applications, which is exactly what it is. It's a nice, light way of us creating containers for us. And we use this to manage our dependencies. What it allows us to do is to put dependencies into an image and to be able to deploy those. It doesn't necessarily solve all of our problems. There are still issues with setting it up, but it does mean that we only need to do it once, and we can store images somewhere in a repository that makes them reusable, unlike a virtual machine. Also, with images, we have less storage overhead than VMs, particularly because you don't need to store the operating system. And so in the case of databases and web servers, that can mean that even though we've got gigabytes of data that we need to move around, we're not transporting all the overhead of operating systems and other things that we don't need in our container. So for us, it's a big win to use something like Docker for that. But this is all very good theory. At some point, you have to get into the real world of how to use it. So at this point, I'm going to hand over to Mario to talk about that. Oh. Sorry, no, I'm not.
Not yet. You'll have to wait a moment to hear me.
This is what happens when you try and do a joint presentation. No, what I want to do first of all, before I hand over to Mario, is to give you a little bit of context about our system. Because, I've talked about Docker and all this wonderful way that it can help us, but it'd probably be nice to know how it's helped us. So I want to introduce you to something which was called the Merchant Feed Service. This was an external API that we were building at eBay a little while ago, and it was designed to allow merchants to bring their inventory onto eBay in a nice, easy, programmatic fashion. As you can imagine, that had some internal APIs that we depended on. It had some proprietary dependencies, and all of that created a little bit of a mess for us when it came to testing, essentially. What we wanted to do is to isolate the merchant feed service and decouple our tests for that from all the other services that we were dealing with in eBay. Now, we had some dependency nightmares. As you can imagine, if you're dealing with third-party or external systems, you might have things which you don't know how well tested they are. You might have a QA environment which is unreliable or just plain slow. And all of that can lead to long testing times or just unreliable tests. And that's the sort of nightmare that you want to avoid when you're running tests continuously. So isolation is key for us. If you're interested in testing one service, you want to be making sure that you're testing only that service. So there's a few steps that we went through to isolate what we were dealing with. First of all, we had to go through the process of decomposing the monolith of the platform, identifying our services, and building up stubs that we can run our tests against, just so that we can focus our testing. Ooh. There's meant to be a nice image here of Stonehenge, the monolithic stones. Anyway, so the monolith, I don't know how many of you have come across platforms with monolithic libraries where just everything is in the platform. A few of you. So maybe you understand the pain and frustration that can cause when everything is magically in the library. It can often be full of anti-patterns or black magic, and it's something which you do see from time to time. And that can be fine if you're just a developer wanting to go and write something, but if you want to test it, it makes life a lot more difficult. So the first thing we had to do was identify services that we're dependent upon. And in a monolithic framework, this can be a bit tricky. It requires a lot of time and patience invested to get that information out. It may require the use of something like a debugger or network sniffer to figure out actually what calls the software is making. But in the end, I think it's worth it because you gain a lot of knowledge about how your system is currently running and how you can improve it. Once you've gone through the process of identifying those dependent services, you can start to apply the Boy Scout rule to it, which is try and leave it in a slightly nicer state than when you found it. So you can start off by moving the configuration for the clients that use or access those services out into some external and versionable configuration. And once you do that, you can update the clients or implement new clients inside the platform to use your new configuration. And by doing that, you start to decouple your application from the environment where it sits, because now you can say, well, okay, if I want to run it under this environment, I just need to provide it this configuration rather than have to provide a whole new binary that's built for that. Once you've identified your test services or your services, you can start to figure out what you need to test through the contract. You can work out what are the APIs that you're dealing with, what are the responses that are expected from the downstream services, and you can come up with a map of that. And the reason you want to do that is to stub it out. The golden rule with that is keep your stubs simple. It's all very well saying, oh yeah, I'm going to create my own third-party dependency, but you don't want to recreate the whole complexity of that dependency. Rather, you create a stub because you want something that's easy to manage, that's simple, and that you can wrap your head around after looking at it for just a couple of minutes. So you might go for having just one response per stub. You might build it on top of something like WireMock or on top of Python with its simple HTTP server. But you keep it really simple so that it just gives you one canned response to one or two particular requests that you put in. From that, you can keep them versioned. You can have a GitHub repository where they live or some other type of repository. And then what's really interesting for us is putting them in containers as a way of managing those stubs so that they come up and go down as we need them for our tests. Finally, once you've implemented your stubs, you know now what dependencies you've got. You know what the contracts look like. You can actually start to write tests. And these tests can then start to test things like the integration of your system, the performance of the system. You can see how your system deals with varying quality of downstream service responses. But what it is important to note here is you are not testing the downstream service. As I mentioned before, you're isolating your tests here on the service that you're implementing. And so you're just focusing on making it as easy as possible to test your service. So the way that we went about it was we started by creating a number of different stubs and putting them inside different Docker images. And then we can just spin up the ones that we need for the specific test that we're running. And then when we're done with that, we can just tear it down and start all over again for the next test. And this is where I meant to say, actually, it's all very well and good talking about the theory, but at some point you do need to get your hands dirty. And I am now going to hand over to Mario to talk about that.
Thank you, Dan. Okay, this is all very nice. We've been like, this is the kind of architecture thing you should do. Let's take a deep dive for the next 15 minutes. So, how do you put your application inside of a container? That's the first thing you want to do, right? I mean, you're using Docker, so you have a Scala application. How many of you actually work with Scala? Oh, good. Okay, the rest of you can probably go to sleep for the next 15 minutes. Or download something, whatever. So the first thing you want to do is you want to have your application Dockerized. You want to actually create a Docker image that you can run your application out of, right? So normally, what do you do when you want to Dockerize an application? Well, first of all, of course, you create your Docker file. Then you build your image. You push it out to some repository, registry. I can keep mixing those two words up. And then you pull down that image from whatever servers you want your application to run on, right? There are a couple of problems, especially with the first two steps. So the first thing is, those of us that work with Scala, we like our static typing, right? We like to have the compiler tell us when we made a mistake. Well, turns out, of course, the Docker file is not compiled and it's untyped. And the only way that you can figure out that you mistyped something in the Docker file is trying to build the image. If you're lucky, you will get an error message. If you're not lucky, you will get something that will basically not do what you expected. Even worse than that, with just a normal flow, it's kind of tough to actually make sure that you are going about it in the right way, that you're doing the workflow correctly, as in, am I pulling in the right bits? Am I pulling in the right artifacts that I need? For example, am I running all the tests before running the image? Yes, of course, you can script it. You can do a shell script, and you can shell script everything. But it's not completely integrated. That's kind of duct tape, right? And also, are you actually putting in, did you remember to compile before creating the image? Okay, so there are some things, and there are some ways of getting around that. And one that we have used is something that actually will allow us to integrate Docker with SBT. So yeah, this little 3D printed piece that can actually integrate any construction kit with any other construction kit. So we would really like to have Docker integrated into our build tool. And of course, if you're working in Scala, mostly you are probably working with SBT. So we're using SBT Docker. And that's a Docker plugin an SBT plugin that will actually do all of that inside of your build. So creating the image, define the Docker file, create the image, and push the image to a registry. Okay. I'm just going to go through some code examples here. You don't really have to read all of the code, but basically, how do you go about it? Well, once you have added the plugin to SBT, you set up your image. You configure your images. Usually, again, you best practice have a tag called latest plus another tag with all the version numbers. You add your versions. You tell it what organization you want to put the image in and what the image name is. Okay, and that's in the image names in Docker task. Then you usually want to have some useful variables. So, for example, I'm using assembly. I'm using SBT assembly to generate a fat jar. How do I know which jar where that jar is or what that jar is, well, have SBT tell me instead of having me figure out where the jar is, and when the project name changes, suddenly the jar is not there anymore. Well, let's have the assembly plugin tell me where it left the jar, okay? And then, of course, there are some bunch of commands that you want to execute, perhaps when you are first creating the image. So there's just some values that I find useful. And after that, you actually go ahead and define your Docker file. So again, that's a Docker file in Docker task. And all you need to do is create this Docker file object, and it has a DSL that basically mirrors the Docker commands. But of course, inside SBT, right? So for example, you have things like, you don't have to worry about the artifact name because it's already there. You don't have to worry, where is the jar? Am I getting the right bits in? You can also add your dependencies in there. I mean, you know that you can basically do anything you want with SBT. So some of the commands are a little bit named differently, but it's basically the same commands that you put in your Docker file. Another thing I like to do, as I mentioned, I'm using SBT assembly. So I always want to have the Docker task depend on assembly. That means that whenever I create an image, it will always compile, it will always run the tests, because assembly depends on test and compile. So that way you ensure that you always have the latest stuff and that your tests are running before creating the image. Then, of course, it's very simple. Inside of SBT, you just run Docker to create an image, and Docker push, and your image magically ends up in whatever registry you have specified. Okay. So again, this makes working with Docker even easier when you're working with Scala. We have found it to be very, very useful, right? Some recommendations, we like working with a fat jar, so either SBT assembly or SBT native packager. SBT native packager also has some Docker support, but I found it to be a lot less flexible than SBT Docker. So I basically use a combination of SBT assembly and SBT native and SBT Docker. And the other thing, since you are running Docker from within SBT, you need to set up your Docker environment before starting up SBT, especially if you're running in non-Linux platforms like a Mac or Windows. You have to set up your Docker environment variables before you start up SBT. And I put it here because I always forget to do that. I go into SBT, I try to run Docker, and suddenly it will not connect to the Docker daemon. Oh, Control D, set up the environment, and start it up again. So that's fine. So we have the first step. We have a Dockerized version of our application. But we're here to talk about testing, right? So let's start talking about other Scala tools that we can use to make it easier to do integration testing with Docker. So, as Dan was saying earlier, you want to create Docker images for all your Docker stubs, Docker images that contain stubs that have all your external dependencies within them. That makes all the tests run faster and the tests be more reliable. You're not depending on whether the other team at that point decided to take down the QA server at the moment that you are running your integration tests, and you're 90 minutes into an integration test run and the test fails because the server is down. So again, you create your Docker images with your stubs, and then of course, before your tests, you need to start up all of the stub containers. You need to wait not only for the containers to start, but for the service that is running inside of the container to actually start, for the stub to start. And then, of course, after your test, you need to tear everything down. And that, I mean, yes, you can do it manually. It's not nice. We, of course, want to automate. So, first thing that comes to mind is to just use any of the normal Docker orchestration platforms. Docker Compose, Kubernetes, whatever. How many of you have tried to do that for things like integration testing? Was it nice? How easy was it to get it to work? I rest my case. So the other way of doing it is to actually orchestrate inside of your test code. So have your test code be responsible for orchestrating, right? So what do? Do we use the Docker Java API? I mean, Docker has a Java API. There's a library that you can control that you can use to control Docker. And yes, you can do that. right? It works. It's not nice. I mean, you have things like, for example, you need to pass in a callback to make sure when the image is already pulled, blah, blah. I mean, if you're accustomed to working with Scala, going back here kind of feels dirty. So you might try to go for some more Scala native solutions. And there are a couple that I found, Reactive Docker and Tugboat. The problem with those two projects is that they have been unmaintained for more than a year. So they do not support the latest Docker APIs. They do not support TLS. And that is an issue with the latest Docker. Especially if you're using Docker machine, for example. You might have an issue with the client not supporting TLS. Okay? And they are actually not using the Docker Java library. They are actually issuing REST calls directly to the Docker daemon. And of course, if the project has not been maintained and the API has been evolving, there are issues. Of course, if anybody wants to actually fork the project, be my guest. But just as an example, and this comes from the documentation of Reactive Docker, this is how it looks in Reactive Docker. So you have things like, you have very nice things like, for example, futures, case classes, and so on. It really makes it nicer, and I really wish it worked. But of course, it doesn't, so we're left so far with using the Java API. But we don't really want all the power and all the control that controlling Docker directly can give us. We have a very specific use case, which is running integration tests. Right? Oh, completely forgot about the slide. So what do you want to do with this? What do you want to do if you have all your stubs, all of your stubs in Docker containers? Well, you might say, let's use a before all in your Scala tests, specs2 tests, to start up all the containers. Let's stop them in the after all. It works, but there are a few issues, like, for example, if each test suite is actually starting up all the containers and stopping all of the containers, it can be slow, right? Again, we need to add checks to see when the resource is up, not just the container, right? Because the container might be up, but the resource might take a few seconds more to start. The other thing is that if you use test only or test quick, well, it turns out that it will start up everything that you put in your before all, right? And sometimes Control-C, especially if you have, cancelable set to true inside of your build, well, it might not stop the containers, right? I mean, we could do that. And that works. But we can go even further. There's this other project I found, and that one is maintained, which is called Docker IT, which is called, oddly enough, Docker IT Scala. And that one will use the Docker Java library. And you basically, what you basically do is you tell your test, you put in your test what containers you need to have started up for this particular test. Actually, for this particular suite. It will actually start up all the containers that it needs when the test starts. So if you are running a test only of a test that needs a single container, it will only start up that single container, even though you have other tests that need 5 containers. It will also start up all the containers in parallel. It will start up all the containers in parallel before the test run. Some people might not like it because they might want to have a completely clean container for every single test. But of course, that's a trade-off, because you might want to, because that will actually slow down your test running. But in this case, I mean, you run your full test suite. It will start up all the containers it needs at the beginning, run all your tests, and then shut them down. Okay? So, how do you use this? Well, first of all, you declare a trait for every single container that you need, for every one of your stubs. Okay? Then you mix that trait into whatever tests it needs. The Docker IT Scala distribution actually includes a bunch of them, but of course you can write your own, and as we will see, it's really easy. This is, for example, a resource, how you would define a container for example, a Neo4j. So you tell it, okay, I want a container based on this image. I want to export these ports, and this should actually be 200, not 7474, typo. And then you say, okay, you need to wait until this URL actually gives you this response code. Okay? So that means that when your test runs, all the services, all the stubs that are running in the containers are started up, not just the containers. And then you just do an abstract override, and you add your container to the Docker containers. This is another example, and this one is Postgres and these examples actually come from the Docker IT Scala docs. Okay, so you can define it in typesafe config if you prefer to define your all of those configurations inside of a config file instead of source code. Same thing. In this case, we have a ready checker that checks for a particular line in the log. And then all you need to do in your trait is just tell it, pull up the configuration from here, from this part in your application.conf. When you write your test then, one thing I forgot is just that all of these actually extend DockerKit or DockerKit config. That's the base trait that all of the containers have, right there. DockerKit or DockerKit config in the case of reading from typesafe config. And then, of course, now all you need to do is have your classes, your test suites mixed into traits. And Docker IT Scala will take care of all the orchestration for you. Okay? We have found it extremely useful. So we have been all the way down to code. Now, take a deep breath and let's go back to the 10,000 feet flight level, and over to Dan.
Thank you. So we've gone really deeply now into how you might go about doing that. But I think what's really important is to know, what did we get from it? Why did we put all of that effort in the first place? So for us, the first effect, and one of the main goals that we were after, was we cut our end-to-end testing time. We took it from 2 hours down to 10 minutes because we removed from the critical path the QA system and using live systems to run tests when all we wanted to do was to verify that our system behaved properly according to the contract. That also means that by doing that, you've now no longer got developers sitting around for 2 hours going, oh, what do I do? Like, the test takes so long. 10 minutes there's still room for improvement, but it's a massive gain for us. And from that, you get some confidence, because if you can have a test cycle of 10 minutes, then you can make much more frequent changes than you can if your test cycle is 2 hours long. So that was one of the main goals for us. But then we can also go further as well. So we've talked a little bit about how you might introduce a framework for swapping in Docker containers for stubbing your tests. But then you might want to take that further, and this is what we did. We use that to start making more decisions based on the characteristics of our application. So the first thing we did is started getting some performance measurements. Now, these were from stubbed tests run on developer machines, but they still give us some important information about the behavior of our system. We can create mocks that can simulate, or at least approximate, real-world conditions, and they may be things like, maybe you've got a system that drops every third request under heavy load, or maybe your network has a 5-second latency that you want to try and recreate somehow, or maybe you just want to know what happens when things are running perfectly and you get an instant response from everything. You can create mocks that can simulate all of those different conditions, and then run some tests against that. And that allows you to start to get some sense of how your system performs. And even if you run it locally on a developer machine, there will be some characteristics that you can extrapolate from that and say, if I notice that there's this kind of behavior under this type of load, it probably will be the same if you run it in a load-balanced round-robin algorithm on 5 or 10 machines. So you can find out how your system performs when it's stressed. You can have systems that are being mocked that respond instantly and just say, well, what happens when I hammer my system? And you could find out how your system performs when the downstream services are tested. So maybe you're not hammering your system, but you've got systems in your containers which are pretending to be stressed, and you can see whether you can respond gracefully to that. And all of that means that you can get some interesting metrics that you can take forward and use to influence the decisions that you make about your project. In short, you can gather all the metrics you want from it. This is just an example of some metrics or some measurements that we found when we were running it on one of our developer machines, the merchant feed service. So just to give you a little bit of explanation, there is the purple line there. This is the threshold for what one of our downstream services could handle. And what we plotted was the number of records that we could process and how long it could take for us to do that under ideal conditions, so when the downstream service responded instantly. And then how quickly it would take us to reach the size limit to get there. So we could process maybe 350,000 records within 10 seconds, which for us was fine. It was in the area that we were interested in. But we could only handle about 50,000 records before we hit the file size limit. And that, although it's just an indication that came from development, it allowed us to make some inferences about how we want to market the system, or how we want to say people can use the system. So in particular, we made a couple of decisions from the graphs. We can think about the technical limitations for the product that we're working on. So maybe we want to say it's reasonable to say that we can only handle 50,000 requests at a time based on what we've seen so far, or maybe we only want to allow certain people to use it who we know are going to provide us with the data to make it worthwhile for them to use it. You could also come up with business policies for the product. So maybe you could say you can only make one batch request per 24-hour period, as an example. But all of that was gathered from just running some local simulations on a developer machine. I think it's probably important to note that this doesn't replace doing full load and performance testing. There's still a case for that. But I think that something like full load and performance testing can often be a lot more expensive to perform and a lot more involved to set up and coordinate, whereas something like this can be done locally in a couple of hours and gives you some idea about how your system may still perform. Okay, so that brings us to the end of what we wanted to say. I think, in summary, we'd just like to leave you with a couple of key points here. First thing is that isolation is key to gathering meaningful test data and keeping testing strategies sane. So in particular, what we're getting at there is, if you only control one system, only try and test your one system. You can't be a maverick hero developer who goes around testing the entire ecosystem. It's just not worth your time. For us, Docker eased the pain of managing the stub dependencies during integration testing, just by giving us a nice, easy way to control which stubs we were working with. And finally, having a meaningful suite of tests can tell you a lot about the behavior of your system, and therefore it can influence both the architecture and the experience you want to provide to your users. And however you get there, you will get some meaningful information from it. Okay, thank you everyone. We've now got time for some questions.
You know, we should really take the questions on the beach.
That was a brilliant talk. I really like that. So questions, I think we have 10 minutes time for questions.
Hello. I have a question about the testing with Docker machine and Docker Compose, in fact. Which are the problems using Docker Compose to testing? Because the problem is when you start the other containers with Docker Compose, you can wait to the open ports or the service or something like that, or which are the problems with that? Because so I use currently Docker Compose a lot, and I have any problem with that, not for testing, for other things, and I don't understand this part.
So some of the problems we found, for example, you might one of them is what you mentioned, that you might start up the container, and if you're running a stub that for some reason takes more than a few seconds to start up, your test might start running before the container is fully started up. That's one. There was also the hassle of having one more configuration file to manage. And also, for example, you might want to have in one of your tests, you might want to have, like Dan was saying, you might want to start up a Docker container that has a service that has a delay built in, for example, or that's not responding on time, or that's returning a 404 instead of 200. Of course, that if you do that, then you cannot run the full test suite. You actually have to run that test in isolation, because it will actually, because Docker IT Scala will actually try to start up all of the containers that you need. But that at least I have found it to be a lot easier to manage that way. I mean, because also another thing is that it helps your documentation for your tests. Because inside of the test code, you're actually seeing in the header what services your code is using. And that can also be invaluable, because sometimes, I mean, you have the service, and after some time, and people have been leaving the group, leaving the team, and newer people have been coming in, there are cases where you say, well, I don't know which services exactly this service depends on. And if you have it with Docker Compose, you're basically starting up all of your containers at the beginning, and there is no relationship between the code and what services it depends on, and except if it's comments, of course, or actually examining the source. Mm-hmm. We have also found it really, really useful for that. And again, I mean, it's just whether you like to do things in, you know, a completely separate ecosystems, or do you want to keep things inside Scala? And that's fair enough. It can be a preference. In our case, we actually prefer to have as much as possible inside of Scala, where it's type checked, where everything is in a single place.
Yeah,
but your mileage may vary.
There were a number of reasons why we chose that, and another one which we didn't touch on there, but something that we found early on was if you've got a number of different types of tests that you want to simulate, then you ended up with half a dozen different Docker Compose files, one for each type of test. And then you have to remember to use the right Docker Compose file to bring up the scenario for that test. Whereas with Docker IT Scala, you can just run the tests and it will go for you.
Okay, thank you.
Okay, I mean, we follow a similar path, but with Docker Compose. But one of the questions a developer in another team asked was, why are you using this? Because you are somehow breaking one of the 12-factor app points to have the similar development environment to your production environment. And you're right now, I don't think you are using Docker containers in production.
No.
Am I right?
No, we're not using Docker containers.
Are you guys
in
planning to do somehow close that gap?
So, I mean, do you want to take this one actually?
I don't know if there are plans to close the gap from eBay's main platform team. eBay has a separate platform team from developers. For us, part of the convenience of doing it like this was to provide a repeatable experience for developers to run these tests for themselves, rather than having to have them rely on, say, the right version of this database to be installed to run the test and this clean script to be run before, or to even just have the right version of Java to run this dependency. So while it does not necessarily satisfy the whole 12-factor app manifesto, it did provide us with that convenience of all you need is Docker in order to be able to run these tests.
There were also another issues. Sometimes our team works remotely, and of course, accessing the corporate servers for running your IT tests can be basically challenging. Not challenging in the sense that you can't, challenging in the sense that you are in a completely different set of circumstances that you are in the real network. Also, if your test, what we found is that if your test suite takes 2 hours to run, you do not run it a lot. You do not really run the test suite before every commit. For example, I don't know if any of you have actually had this problem. Okay. So one of the things we said, well, we want to, that was, okay, so it was that we wanted to bring down the running time to something that's reasonable. We also wanted to, again, like Dan was saying, test our system, not test everybody else's systems as we are testing our own. We have found problems, like I was saying earlier. You run your IT tests, and suddenly one of the teams, one of the QA servers of the team that you are depending on, that team has done some maintenance or something and brought the server down. So now your IT tests, after 90 minutes of running, crash. And you don't know whether that problem is a problem with your code or a problem because the other system crashed. So we still have the IT tests that also exercise external systems, but those get run just by the CI server. But for day-to-day working on your machine, when running on your machine, you don't want to do that, basically. So again, it's a little bit of balance. It's a balancing act.
Yeah, but 10 minutes also locally, it's a lot of time.
Yes, it is.
To, make a change in a class and wait 10 minutes for feedback? I don't know if I would do that.
Yes, I mean, fair enough. I mean, it's 10 minutes, but it's not. You might run those. For example, the IT tests, we usually run them just before doing a commit, not after each change. Mm-hmm. Okay, and they do get run a lot more often since we took that time down. It's not perfect, like Dan was saying earlier. It's not perfect, but it's a lot better than where we were.
Thanks.
Hi. I think the answer you already are going to give me the same answer, but one of the problems with the stubs, I mean, it's a good idea to stubs, but then at some point you have to verify that the stub and what the dependencies does is basically that you don't break the contract. How do you verify that?
I think that depends on where you draw your test boundaries. So we have more tests than just integration tests. We have contract tests in place as well, which will verify that that the part of our system which interacts with the external system meets that contract. And we also have full end-to-end tests which verify if we run a couple of key flows that everything runs through in the right particular order. What we're doing with these stubs are just verifying that if we assume that the downstream services or third-party services are behaving according to their contract, then we behave as we expect to. So we have more tests in place to check that the actual contract is still valid.
And just to go a little bit deeper on that, what might happen is the contract test basically runs one case of each possibility in the contract. Whereas if you're running the full test suite, you might be accessing one specific service 10, 20, 30 times. So even with the contract tests that actually are accessing the external systems, the test suite still runs a lot faster. Yeah. Yes, of course, of course.
So I have two questions. One, do you have some idea what the breakdown for latency is when you're bringing up the Docker environment? Like where you're spending the most time in that 10 minutes? And my second question, I forgot.
Okay. That's great. I forgot the answer to that question too.
Yeah. Okay. So I think that to answer that question, most of the 10 minutes there is because it's actually on us putting a lot of data through the system under a lot of different scenarios rather than waiting for machines to come up or for containers to do their job. It's just a reflection of the type of test that we're running in that suite at the moment.
Okay, any more questions? If not, a big thanks to Daniel and Mario.
Thank you.